Good morning, students. How are you? This is Ankit Joshi. I welcome you all to India's largest live learning platform, Gradeup. And today we have brought a very important topic from probability, that is total probability in Bayes theorem. And for your information, in today's class, we will be learning the basic concepts, the concept behind this Bayes theorem and total probability. We'll solve some fundamental problems. And in tomorrow, there will be a complete practice session on this topic at the same time, 9 a.m. This is about me. I have been teaching in this domain for more than 15 years. My subjects of interest are engineering, mathematics, analog circuits, and signals and system. So this is with regard to the batches currently going on Gradeup platform. These are the faculties who will be dealing with the batches regarding ECE branches. Along with me, you can see Rakesh sir, Sanjay sir, MN sir, Chandan sir, and Chaitanya Reddy sir. These are our previous achievers, and if you are really aiming at GATE 2021 and see if you are a serious preparation, doing serious preparation, then definitely you will be one among this frame. There are some characteristic features of this green card subscription. You can take the screenshot and just contact at the number given below if you have any queries related with this. Now, Gradeup has brought some exciting offer for you during for subscription regarding you can avail a 40% discount, and this discount will continue only till midnight today. Okay, so this 40 you can avail this offer for 40% discount only up to midnight 12th of December, that is today. So I will start the session. The entire probability can be split into two parts. One is the organized approach and another is the unorganized probability. So unorganized probability involves the concept of events, total probability, and Bayes theorem. So when we talk about the events, which are the important events that we have to consider? The important events are mutually dependent, mutually independent, mutually exclusive, and collectively exhaustive. Just go through this frame. So if you have a clear-cut understanding of the events in probability, then it will be very easy for you to understand and apply the concept of total probability and Bayes theorem. So mutually dependent events, first one, mutually dependent events. Suppose you are having a premises whose entry gate is named as E. You are having a big premises for which the entry gate is named as E. And inside this premises, there is a room whose entry is through gate B. Okay, so a very simple question to you. I want to reach here inside gate B. I want to reach here inside gate B. Is it necessary for me to take entry from A, or without taking entry from A, I can reach B? Tell me. So it is compulsory for us to take entry from gate A in order to reach gate B. Okay, so I can say that B is dependent on A. B is dependent on A. But at the same time, can we say that A is dependent on B? Can we say that A is dependent on B? No, no, not at all. So A is independent of B. Correct? So in this context, B is dependent on A and A is not dependent on B. A is independent of B. Still, in the context of probability, we found that it is written everywhere that A and B are mutually dependent. In the context of probability, that is, I am talking about probability problems. In probability problems, this type of situation will be referred as A and B are mutually dependent. So if somewhere you get this statement by solving probability problems, if somewhere you get this statement A and B are mutually dependent, then it is your responsibility to read that question once or twice and get out the inference, take the inference that which event is dependent and which event is independent. Okay. So by reading the question, you will come to know that though they have given you A and B are mutually dependent, but still there will be only one event which is dependent and the other will be independent of the first one. Okay. So if you get this type of statement, A and B are mutually dependent, then read the question and find out of A and B, which one is dependent and which one is independent. Okay. So as it is apparent from this diagram, apparent from this case, that here B is dependent on A, but A is not dependent on B. Okay. Still we says that A and B are mutually dependent. Now we are interested in the simultaneous occurrence of A and B. It means we want to determine the probability of simultaneous occurrence of A and B, or simply probability of occurrence of A and B. This probability is denoted by P of A intersection B. How will you read it? How will you read it? So this is probability of A and B, or this is also called as joint probability of A and B. This is joint probability of A and B. Okay. So this joint probability of A and B will be equal to the product of the individual probabilities of A and B. But here B is dependent and A is independent. So always remember that for dependent event, you have to write the conditional probability. And for independent event, you have to write the simple probability, what is also called as marginal probability. I need your response on this. I need your concentration. So I need joint probability of A and B. I need joint probability of A and B. So this will be the product of individual probabilities of A and B. But now you have to see which event is independent and which event is dependent. So here A is independent. So for A you have to write the marginal probability. Marginal probability of A will be written as P of A. And similarly, conditional probability of B can be written as probability of B. Now B is dependent on which event? B is dependent on A. So this is probability of B given A. It is not divide, it is given A. So joint probability of A and B is equal to one marginal probability and one conditional probability. How will you read this conditional probability? Conditional probability of B given that A has already occurred. Conditional probability of B given that A has already occurred. Conditional probability of B given A. Conditional probability of B given A. So here we can say that P of A is nothing but the marginal probability of A, and P of B given A, this is conditional probability of B given A. Okay, sir. So can we say that this joint probability is equal to marginal into conditional? Yes. So I am just abbreviating this so that you will be easily able to realize this, remember this. So joint probability is equal to marginal into conditional. So joint probability is nothing but probability of A intersection B, and marginal probability of which event? Marginal probability of that event which is independent multiplied by conditional probability. Conditional probability of which event? Conditional probability of that event which is dependent event. So okay, so here A and B are mutually dependent event. So in case of mutually dependent event, how to write the conditional probability? That concept we have seen here. This conditional probability of this joint probability of A and B is equal to the product of one marginal and one conditional probability, and this was the first event, that is mutually dependent event. I request all of you to take the screenshot. It will be very helpful for you to use in your future reference. Now requesting all of you to hit the like button. Now suppose if you change the scenario, and this is your entry gate B, and this is your small room inside this premises whose entry gate is A. Now here I can say that B is independent and A is dependent on B. Still you will say that A and B are mutually dependent. Okay, yes sir. So we are interested in the joint probability of A and B. So how to write it? This joint probability is equal to one marginal and one conditional. So marginal probability of which event? Marginal probability of which event? The event which is independent. So B is independent. Then conditional probability. Conditional probability of which event? Conditional probability of the event which is dependent. So A is dependent on B. So probability of A given B. So this is how we write the conditional probability. This is how we write the joint probability for mutually dependent events. Is that clear? So the first case was mutually dependent events. In case of mutually dependent events, the joint probability will be, say, marginal of A into conditional of B given A, provided A is independent and B is dependent. Okay. This is the situation. Now, second case is mutually independent events. Mutually independent events. See here. Let us say event A is getting head on a coin toss. And event B is getting a particular number, say 3, on a die toss. Read this event. What is event A? You are having a coin, tossing it. If head occurs, then you will say that event A has occurred. What is event B? You are having a die. You are tossing a die and getting number 3 on the die toss is event B. Now, I am having this coin and die together in my hand. I am having this coin and die together and I am going to toss it. So my question to you, will the occurrence of head on the coin affect the output of die toss? No. Will the occurrence of output of die toss affects the output of coin toss? No. It means getting head on a coin and getting 3 on a die toss, both are independent of each other. Both are not affecting the probabilities of occurrence of each other. Okay. So even if you calculate the joint probability of A and B, in that case, it will be simply the product of their marginal probabilities. So no event is dependent on the other. So getting head is not dependent on the die toss outcome. Getting 3 on a die toss is not dependent on the coin toss outcome. So ultimately, joint occurrence, probability of joint occurrence, or you can say joint probability of A and B is simply the marginal probabilities of A and B, product of marginal probabilities of A and B. Remember this. So this is mutually independent events. So in case of mutually independent events, joint probability will be P of A into P of B. So mutually independent events. In case of mutually independent events, joint probability of A and B, that is probability of A intersection B, will be P of A into P of B. Very important. Then next. Now what is the third event? Third event was mutually exclusive. Suppose event A is getting head and event B is getting tail on the same coin. Now, can head and tail occur simultaneously? Can you get head and tail occurring simultaneously? No. It means I want to find out the ways in which A and B occur simultaneously. So I will not find any way in which A head and tail can occur simultaneously on the coin toss. So A intersection B will be an empty set. So how many elements are there in this set? 0. So when you calculate the joint probability of A and B, numerator will be 0 and hence the probability will be 0. Yes. Now such type of events are called as mutually exclusive events. What are they? Mutually exclusive events. That is, when one event occurs, other event will not occur. So when A occurs, B will not occur, and when B occurs, A will not occur. Only one will occur at a time. You would have heard about Shah Rukh and Salman, the celebrities, had some dispute, some quarrel. So if they were invited in a party, if Shah Rukh attends a party, Salman won't attend the party. If Salman attends that party, Shah Rukh will not come to that party. It means if we say that both are events A and B, then simultaneous occurrence is not possible. So there is no such way in which both the events can occur simultaneously. So such events in which A and B cannot occur simultaneously, they are called as mutually exclusive events. That is, when A occurs, B will not occur, and when B occurs, A will not occur. So mutually exclusive events. In case of mutually exclusive events, the joint probability will be 0. See the third case. For mutually exclusive events, joint probability of A and B will be 0. Got it? No response? Requesting all of you to hit the like button. We'll move to the next. Next is collectively exhaustive events. See, suppose you have two events such that sum of their probabilities is 1. Then we will say that A and B are collectively exhaustive events. Or the same rule can be extended for more than two events. Suppose you are having three events, sum of whose probabilities is 1. P of A plus P of B plus P of C equal to 1. In that case, you have to say that A, B and C are collectively exhaustive. Okay. Sir, what do you mean by collectively exhaustive? Mathematically it is written, but I'll take one small case. Suppose you are installing a small production unit in which you are outsourcing, you are getting the outsourced work of some big production unit. Suppose you are producing some particular size of screw. Okay, so you have got some work from some other production unit. Now you have two machines, machine 1 and machine 2. Machine 1 is contributing 60% and machine 2 is contributing 40%. To what? To your requirement. So when you collected the objects being produced by machine M1 and machine M2 together and you randomly select an object randomly select an item from the total production, then what is the probability that that particular item is being produced by machine M1? That is 0.6, 60%. And what is the probability that that item is being produced by machine M2? It will be 40%, 0.4. So it means if I add these two, I am getting 1. Consider the second case in which your machine M1 is contributing 40%, machine M2 is contributing 30%, and remaining work is outsourced. You also outsource the remaining work. Okay. Now, if this total production is collected together, and if you find a defective object, then that defective object can be made from machine 1, can be made from machine 2, or it can be from the outsourced work also. Okay. Now this time in second case, you cannot create an accountability on machine 1 or machine 2, because there is always a chance open that that defective object being produced by some external outsourcing work also. Okay. So in the second case, when you try to add the probabilities of machine M1 and machine M2, that will not be 1. So in this case, you cannot develop an accountability on the items being produced defective. Okay. So this is a very good example, classical example of collectively exhaustive event, that you are having two machines, their total production is meeting your requirement. If your total production is not meeting your requirement, you are outsourcing some work, then there is always a chance open that if there is a defective item, you cannot hold the responsibility. There is always a chance open that that defective object being produced by some outsourced agency also. Okay. So if some of the probabilities, some of the probabilities of these events is 1, you can say that the set of events are collectively exhaustive. If the sum of the probabilities is less than 1, you have to say that the events are not collectively exhaustive. This is the concept of the events. So we have got 4 events: mutually dependent, mutually independent, mutually exclusive, collectively exhaustive, and there are different conditions. There are different mathematical approaches. Can I have your response in the comment box? Any doubts you have? Chalo. We'll move to the next. Good morning, Nidhi. How are you? Great. Now, Raj, thank you, beta. Thanks for your response. If you have not liked the session, you can hit the like button. Now, moving to the concept of total probability and Bayes theorem. And I would always Mithun, you just watch my lecture from the beginning. I explained the same thing. Mutually dependent means something which is dependent on each other. And independent means when the outcome of one event is not affecting the outcome of the other. If your friend's father is getting salary, then you will not be getting salary or not. Your family is not affected due to it, and your father is getting salary in time, so it will not affect your friend's family. So these are mutually independent events, mutually independent cases. Okay, but when it comes to your family, it means your father's income, your father's salary will be definitely affecting you and your family, means whether he is getting the salary in time or not. Okay, so you have to think in such a manner that you should develop some understanding. Chaitanya, I will not be indulging anything which is irrelevant as far as this session is concerned. What is the topic? Topic is probability and Bayes theorem. So anything related with this we'll discuss, and that too I will discuss, and if you have any doubts regarding my discussion, that can be sorted out. We have to be in scope. So coming on to the concept of total probability and Bayes theorem, I will develop this concept with this small story, that there is a person, there is a student in your school or college who is not good at studies. Okay, his name is Laddu. Laddu is not good at studies, but he is always doing some mischievous actions in the school or college wherever he studies. He may be your classmate. Now, what happens? He is caught red-handed by while doing some mischiefs in the class. So the professor has given him the warning that he will not allow him to pass now. So Laddu was very afraid. Laddu was very afraid and bothered how he will pass the exam now. So Laddu was sitting in the college lawn. So two of his friends are there, A and B. Now A and B are such events that they will not come together always. A and B are two friends of Laddu who are bitter enemies among themselves. Means A and B are not friends with each other. Not friends, means they are enemies. But they are friends with Laddu. They are friends of Laddu. So this event E denotes Laddu passing the exam. Laddu himself cannot pass the exam because he is not good at studies. He is a duffer student. So to pass the exam, he has to rely on A or B. He has to rely on A or B. Okay. Now A and B are enemies. It means when A is helping Laddu, B will not help, and when B is helping Laddu, A will not help. So A and B are mutually exclusive. A and B are mutually exclusive. A and B are mutually exclusive events. That is, when A occurs, B will not occur, and when B occurs, A will not occur. So when A is helping the Laddu, when A is helping Laddu, B will not help, and when B will help Laddu, A will not help. Apart from A and B, event E cannot occur through any other way. It means E has to rely only on A or B, not anything else. Okay. So event E can occur with the help of A. Event E can occur with the help of B. These are the two ways by which event E can occur. But when A is helping E, when A is helping Laddu, B will not help, and when B is helping, A will not help. So you have to consider two events. A and B. You have to consider two events A and B, which are mutually exclusive and collectively exhaustive. Consider two events A and B which are mutually exclusive and collectively exhaustive. It means when A is helping, B will not help, and when B is helping, A will not help. Understood? So A and B are two boys in the same class, and there can be multiple reasons for their enmity. We do not want to indulge in that enmity. Why they are not friends with each other? Okay. So it, it purely depends on the nature of A and B. Now, A and B are mutually exclusive and collectively exhaustive. It means we have an event E which can occur we have an event E which can occur either with the help of A or with the help of B. We have two events which can occur. We have two events A and B. We have another event E which can occur either with the help of A or with the help of B. Okay. Now see here. Think A is Laddu's friend who is helping Laddu to pass the exam. And event E is Laddu passing the exam. Event A is A passing the exam. Okay. So see here. We can say that E is dependent on A. So joint probability of E and A will exist. Similarly, we can say that E is dependent on B. In the second case, E is dependent on B. E can occur with the help of B also. So joint probability of E and B exist. Okay. Now in this upper path, E is dependent, A is independent. Yes, E is dependent on A. Laddu depends on A, but A does not depend on Laddu, correct? So A is independent. So joint equal to marginal into conditional. So marginal probability of independent event and conditional probability of dependent event. Conditional probability of dependent event. Out of A and E, which one is dependent? Sir, E is dependent. So E is dependent on A. Probability of E given A. So when Laddu passes the exam, when event E occurs, through this upper path with the help of A, what will be the scenario? Probability of simultaneous occurrence of E and A. This is joint probability of E and A. Joint probability of E and A. This will be equal to one marginal and one conditional. This will be the product of marginal into conditional. So marginal probability of whom? किसका marginal probability होगा? Marginal probability of the independent event. So in this path, upper path, independent is A and dependent is E. So marginal probability of A and conditional probability of E. If the event E is occurring with the help of B, that is lower path execution, then E and B are mutually dependent. That's damn true. But in reality, B does not depend on E, but E depends on B. E depends on the help of B, but B does not depends on E. So B is independent. So for the independent event, you have to write the marginal probability, P of B. And for E, you have to write the conditional probability. Conditional probability of E given B. Conditional probability of E given B. Is that clear? So, once again, listen carefully. There is a duffer candidate, very poor candidate in your class. His name is Laddu. Event E denotes the event of Laddu passing the exam. Laddu cannot pass by himself. Laddu can pass the exam either with the help of A or with the help of B. A and B are two friends of Laddu, but A and B are not friends among themselves. A and B are bitter enemies among themselves. A and B represents mutually exclusive and collectively exhaustive events. There is another event E which can occur either with the help of A or with the help of B. Then E can be executed. E can occur either with the help of A, that is upper path execution. E can occur either with the help of A or with the help of B. So when E occurs with the help of A, then you have to write a joint probability between A and E and A. When E occurs with the help of B, you have to write a joint probability for E and B. And we know that joint probability is marginal into conditional. Marginal probability किसका लिखेंगे? Whose marginal probability you have to follow? Marginal probability of the event which is independent. So in this upper path, which one is independent? I need your response. In this upper path, which one is independent? A. So P of A multiplied by joint equal to marginal into conditional. So conditional probability of the dependent event, that will be probability of E given A. Then joint probability of E and B will be marginal into conditional. Marginal will be P of B, conditional will be P of E given B. So now event E, probability of occurrence of event E can be upper path or lower path, this or this. So this will be P of E intersection A, or means plus P of E intersection B. P of E intersection A or P of E intersection B. So this concept is called as total probability. So what is total probability? Total probability can be defined as a case study where you have two events A and B which are mutually exclusive and collectively exhaustive. There is another event E which can occur either with the help of A or with the help of B. Then the probability of occurrence of event E is given by P of E intersection A plus P of E intersection B. Okay, and you can further write the expansion of this P of E intersection A and P of E intersection B from these expressions. Okay, this is total probability. Now see here. Consider two boxes, box 1 and box 2. We have two boxes, box 1 and box 2. Box 1 contains 4 red and 6 black balls. Whereas box 2 contains 5 red and 5 black balls. Now a coin is tossed. So what are the outcomes of a coin toss? Head or tail? If head occurs, then one ball is randomly drawn from box 1. If head occurs, then one ball is randomly drawn from box 1. So you have tossed a coin. If head occurs, one ball is randomly drawn from box 1. Whereas if tail occurs, then one ball is randomly drawn from box 2. Achha. When tail occurs, one ball is randomly drawn from box 2. Got it? Find the probability of getting a red ball. Okay. So you can see here, what is the probability of getting red ball from this box? 4 upon 10. What is the probability of getting a red ball from this box? Red balls are 5, total balls are 10. So 5 by 10. Okay. Now see this scenario. You can get a red ball from box 1. You can get a red ball from box 2. So there are two possibilities. There are two ways in which you can get a red ball. What is the probability of selection of box 1? Probability of selection of box 1 will be probability of head. And probability of selection of box 2 will be probability of tail. Correct? So if already box 1 is selected, what is the probability of getting red ball? If already box 1 is selected, what is the probability of getting red ball? It is 4 by 10. If already box 2 is selected, what is the probability of getting red ball? Already box 2 is selected. What is the probability of getting red ball? It is 5 by 10. So probability of red ball and selection of box 1 simultaneously. This will be, joint probability will be marginal into conditional. Marginal for B1 and conditional for this R, that is R given B1. So product of these two, 1 by 2 into 4 by 10. That will be 4 by 20. Similarly, probability of joint occurrence of red ball in box 2 selection. This will be marginal into conditional. So 1 by 2 into 5 by 10, that is 5 by 20. So ultimately, probability of getting a red ball. So this red ball can be obtained either from the upper path or from the lower path. That is addition of this one or this one. Or means plus. So this will be 4 by 20 plus 5 by 20. That will be 9 by 20. This is the scenario. Take the screenshot of this. This is the first frame. Now, event E. This is the probability of occurrence of event E. Okay. Now, event E has already occurred. 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 What is the probability that it occurred via A? Event E has already occurred. What is the probability that it occurred via A? Similarly, event E has already occurred. What is the probability that it occurred via B? So, these probabilities we have to calculate. Laddu already passed the exam. Now we want to know what is the probability that he passed the exam with the help of A. So, probability that event E has already occurred. What is the probability that it occurred via A? So this is a conditional probability. See, joint equal to marginal into conditional. So conditional will be joint upon marginal. So joint of these two will be A intersection E, and marginal. Whose marginal probability you have to write? The event which is written on the right side of this slash. So right side of slash is E. So marginal probability P of E will appear in the denominator. So conditional probability will be joint upon marginal. Joint B intersection E upon marginal P of E. And we know that intersection operation is commutative. That is A intersection E can be written as E intersection A. B intersection E can be written as E intersection B. See, event E has already occurred. Event E has already occurred, and we are interested in the path through which event E has occurred, and this is probability that the event E has already occurred. What is the probability that it occurs via path A? Event E has already occurred. What is the probability that it occurred via path B? So these calculations are done using Bayes theorem. This is Bayes theorem. So Bayes theorem has got these two statements. If suppose there is one more event C in the chain, then there will be probability of C intersection C given E. Okay, so in this or satisfying this case, you have these two statements for Bayes theorem, these two formulas for Bayes theorem. So it should not be learnt as a formula. It should not be learnt as a formula. It should be learnt as a process, so that you will be able to apply in any other cases also. Now in this case, they are saying that if the ball obtained is red, what is the probability that it comes from box 1? It means they are saying that ball obtained is red. What is the probability that it comes from box 1? In the third case, they are asking if the ball obtained is red, what is the probability that it comes from box 2? So first case was total probability, and these two cases are Bayes theorem. Okay, so if the ball obtained is red, what is the probability that it comes from box 1? So this is conditional. It will be joint upon marginal. Joint in the numerator. R intersection B1 upon marginal of R in the denominator. Similarly, if the ball obtained is red, what is the probability that it comes from box 2? So this is also conditional. Joint upon marginal. R intersection B2 upon P of R. So R intersection B1 is already there on the previous frame. R intersection B1 is 4 by 20. And P of R 9 by 20. So 4 by 9 is the probability. If the ball obtained is red, what is the probability that it comes from box 1? Probability is 4 by 9. Now, probability for R intersection B2. R intersection B2 is 5 by 20. And probability for getting red ball, that is total probability, is 9 by 20. So answer will be 5 by 9. So I hope you would have understood this application of Bayes theorem, how we applied the concept of total probability in Bayes theorem. Yes. Requesting all of you to hit the like button. So the first question was approached through total probability, and the other two questions are approached through the Bayes theorem. So we started with the events. We first dealt with the 4 types of events. Then we learned the concept of total probability, and then we moved towards the Bayes theorem. So you can take up one example as the homework. Contents of U3 are also given. U1, U2, U3 with 3 urns. U1 contains 2 white, 3 black balls. U2 contains 3 white and 2 black balls. And there is U3. Content of U3 is 2 white and 4 black balls. Okay. So this is your homework. We'll meet tomorrow 9 a.m. in the morning, solving some questions based on the same concept, total probability and Bayes theorem. Thanks a lot. Do follow me on Gradeup app. Do provide a productive feedback in terms of your comments, and do like this session. Bye-bye. Thank you. Tomorrow at 9 a.m.